let us look at the Fischer projection of two chiral carbon atoms and try to understand a kind of conversion. Now, this is the wedge representation. I am taking this molecule. So, in this wedge representation, COH and COH and this line are in the plane of the board. OH and H are into the plane of the board and outside the plane of the board. Now, for the top carbon atom, this will be H, this will be OH, COH is like this. For the top carbon atom, this will be H, this will be OH, COH is like this. And for the bottom carbon atom, again, okay, I said it wrong. For the top carbon atom, OH is outside, this is OH, H is inside. For the bottom carbon atom, the representation is H is outside and OH is inside. So these are the two carbon atoms. So they have different configurations on both the chiral carbon atoms. This is a chiral carbon atom, this is a chiral carbon atom. Now what we are doing is converting this into Fischer projection. So to convert this into Fischer projection, the COH group, which is the important functional group, should come on vertical line. Vertical line means what? This is COH assume. It should be inside the plane of the board. So I am twisting the top carbon atom like this. Automatically the bottom COH also will be twisted like this. Imagine this. This is COH, this is COH. I am twisting the COH into the plane of the board. So both the COH goes into the plane of the board. So that makes, previously which group is outside? OH is outside. Now OH comes outside but to this side. H previously was inside but that is also coming outside. So that is what is the top chiral carbon atom. OH to the right, H to the left, but both are projected outward. That is like this. But COH is now inward like this. So the other carbon atom, if I am putting like this, the other COH also will be inward. So this is the other carbon atom. So what is along the plane of the board? You have to imagine this line only. Only this line is along the plane of the board. Now this COH is inside, this COH is also inside. That is how the molecule is. Okay. So now, so these are the two OH group. This is the OH group, this is the H group. On the bottom carbon atom, previously what is outside? Previously hydrogen is outside. Now this is the bottom chiral carbon atom. So this hydrogen that is outside will come this side. So the OH which was previously inside also will come outside. Now these two groups are outside and inside. So this is hydrogen and this is OH. The COH which was like this previously, now this also has turned inside. So this is COH, that is COH, one line, H and OH, OH and H. That is how the groups are aligned. That is what this Fischer projection represents. Now I want you to understand the same Fischer projection I am taking, the same wedge representation I am taking, just I am interchanging the configuration of this group. That is, now this COH is towards this side, this hydrogen is inside, this OH is outside. Now what is the difference between this wedge and this wedge? This wedge, if you look from this side, that is eclipsed conformer. What is eclipsed conformer? Eclipsed conformer somewhat looks like this. Behind the COH there is a COH. Behind one group there is some group. Behind this group there is another group. Behind this group there is this group. So all groups fall behind each other. That is eclipsed conformer. For eclipsed conformer only we are writing the Fischer projection. Why? Because COH should fall behind COH. H and O, these two horizontal groups are behind each other. These two horizontal groups are behind each other. Now suppose the wedge representation is given in staggered conformation. Staggered conformation, how does it look like? The COH and COH are not eclipsing each other. They are in different directions. So if one COH is inside, you have to say one COH is outside in this representation. One COH is inside, the other COH goes outside. Two groups are like this, two groups are like this. So that becomes a little unsuitable for Fischer projection. So what we are going to do? We are going to convert the staggered into eclipsed form. So if this is the staggered form, where behind, downward if you move along the COH there is nothing. Downward these two groups there is nothing. If you join them, if you collapse this bond, everything will pass through it. So that is what is this staggered form. Now how to convert the staggered into eclipsed? Now COH is in this direction towards me. So there is OH towards you. OH is this is the bottom carbon atom. OH is towards you. H is inside, COH is towards me. But in the above carbon atom, COH is in that direction, H is in this direction, OH is in this direction. You can have a look now. So what am I going to do? I am going to twist this such that this COH goes there. So now after this rotation, COH is also inside. above COH is also in this direction, this COH is also in this direction along the plane of the board. So previously in the bottom carbon atom, OH is towards outside, now OH goes inside. That is what is this. OH is going inside, H is coming outside. Now both COHs are in one line. Here these two groups like this and like this, COH like this and like this. So that means it has become again eclipsed form. Now look at this Fischer projection. OH is towards which side? Inside. COH is on the plane of the board. But we want the most important functional group to be on the vertical line. So what am I going to do? This is COH group. I am keeping this in the vertical line like this. So that is the COH group. So that becomes the COH group. So previously OH is here. Now after rotating, OH is here. Previously hydrogen is inside. That is why dashed line. Now after this rotation, hydrogen is to the left. That is what is this left. And look at the bottom carbon atom, COH is like this. H is to the outside. H is to the outside. OH is to the inside. So what am I doing? I am again doing a twist. So H comes to the right, OH comes to the left, COH goes down. So now this molecule looks like COH inside. This line on the plane of the board, again COH inside. The groups are obviously opposite. Keep that in mind. So that is the Fischer projection. So always to write Fischer projection for two carbon atoms, try to write it in eclipsed form. It will be easy to think about it in mind. Then you will be able to do it. If it is staggered form, even horizontal groups go inside. That's a problem. Vertical group might come outside. That's a problem. That is why write it in eclipsed form. Also, you can convert this into Newman projection, Sawhorst projection also. But you can do it in your mind. So this is the conversion of two carbon atom Fischer projections.